can move on to question number 2. Which of the following properties would you expect to be different for the 2 enantiomers of 2-pentanol? Okay, so this is question number 2. I'm just gonna make like some comparison table. So I'll put on the left like same properties. For 2 enantiomers. And then on the right side, I'll have the different properties. So that everything is organized. Okay, so first they talk about boiling point. So the boiling point will actually be the same for 2 enantiomers. So the overall like chemical compound structure doesn't like really change. So boiling point isn't affected. Next we have optical rotation. So this is an example of a property that would be different. Okay, so next we have solubility in hexane. So hexane is an example of an achiral molecule. So therefore, its solubility in hexane would be the same. Then I'll just put in brackets achiral. D density, so this is another example of a property that would be the same. Solubility in S3-methylhexene. So this is kind of like the opposite of our hexane option. This would actually be different for 2 enantiomers. And this is because S3-methylhexene is a chiral molecule. Solubility in S3-methylhexene. Okay, so the next one is dipole moment. This would be the same for the 2 enantiomers. So dipole moment occurs when one atom is more electronegative than the other. So there's an uneven sharing of electrons, and the electrons move toward the more electronegative atom. So if we had 2 enantiomers, since they basically have the same chemical structure, the dipole moment would still be the same no matter what direction it's going. So dipole moment is the same for 2 enantiomers. And then lastly is taste. So they give us a helpful hint that says your taste buds are chiral. So we can already put taste on the right side of the chart. Since taste buds are chiral. Okay, so let's check out the answer from our junior tutor. The boiling point of enantiomers is always similar. Since the net total atoms does not change in the molecule, their densities will also be equal. Dipole moment does not depend on optical activity. Taste can be different for enantiomers. Optical rotation of enantiomers are opposite and different. Yep. Solubility in S3-methylhexene is different for enantiomers of 2-pentanol. So the answer is test, optical rotation, and solubility in S3-methylhexane. This is well written. It is also correct. Okay, so now we will move on to question number 3.